Hello everyone, and welcome to our webcast tour of database platforms as a service. I am Warner Chaves, Principal Consultant with Pythian. Allow me to introduce myself. I've been a DBA and consultant for 10 years. I used to work as a level 3 DBA at Hewlett-Packard in Costa Rica, and I'm now a Principal Consultant at Pythian in Ottawa, Ontario, Canada. I'm also a Microsoft Data Platform MVP. Feel free to reach on Twitter at warchav, and please make sure you visit our website at pythian.com. The topic for today is we're going to be doing a high-level overview of the main database as a service offerings in the major public cloud providers. So, since we are going to focus on public cloud providers, we're going to cover offerings from Amazon, Google, and Microsoft in this particular webinar. Like I mentioned before, the scope today is going to be completely focused on public cloud providers, so I'm not going to be talking about private hosters or type of colocation environments. That's not the focus for today. It's going to be also focused on platform as a service offerings. So we're not going to be focused on how to run your favorite Hadoop distribution or your favorite relational database on infrastructure as a service virtual machines. We're also going to focus on repositories or analytics services. So these are services where the data will go into rest, not services that work on data in transit. So we're not going to talk about the different streaming or data orchestration type of offerings in the cloud. We're going to focus exclusively on repositories or analytics services for data. It's not an exhaustive list as well. These are the ones that I have worked with and that I find very interesting, but again, it's not an exhaustive list. And in the end, it's high-level overviews. I am not going to go into major detail on each one of these offerings. Each of these could probably be a full-blown couple of days class. So it's just high-level overviews so that you as a viewer will be familiar with all the different database as a service offerings in the public cloud just by consuming this webinar. So, what do I mean when I talk about, a database as a service offering or a platform as a service offering? Well, first thing, the service has to be able to be contracted with no type of long-term commitment. So it's a public cloud provider, and I should only need my credit card to start an account and start some service and start getting some compute power and start storing my data. It should not be any more complicated than that. For it to also be considered a database as a service, I should have nothing to do with the operating system or anything below the operating system. So I shouldn't have to manage the operating system, patching the operating system. I shouldn't have to manage any sort of hypervisor. I definitely should not have to manage anything that has to do with actual bare metal hardware. Third, I should be able to scale up or down on demand. So if I need more power, I should be able to scale up the service. If I am ramping down the service because it was a type of one-time high CPU that I needed event, then I should be able to scale it down just as well. I should also be able to create and destroy environments on demand. So for example, if I have SQL database as a service somewhere in the cloud, I should be able to just uncode, spin up a new copy of that database, let my dev or test guys work with it, and then destroy it as soon as they are done. So that type of flexibility, again, is paramount to the power of what we can get for these type of platforms. So if a service does not offer that type of capabilities, they are not, in my opinion, qualified to be called a database as a service offering. And finally, the core operational tasks should all be provider managed. Now, when we talk about core operational tasks, I mean things like having to keep up with your backups, having to keep up with your high availability, definitely any sort of patching like I mentioned before, or all these should be managed by the service provider, be it Amazon, Google, or Microsoft in this case. Okay, so let's talk about the first category of the database as a service offerings that we're going to go through today. And this is what I call the COROLLAS. So this type of service, you know what you're getting and you know what to expect. It's great to get you from point A to point B. It might not be the flashiest or newest thing in the block, but it gets the job done. And by that I mean the different relational database services that we have in the cloud now. So the number one, I would say this is probably the granddaddy of database as a service in the internet, is Amazon RDS, Amazon Relational Database Services. So RDS is basically an automation layer that Amazon has built on top of MySQL, Oracle, PostgreSQL, SQL Server, and Amazon also made its own MySQL fork called Aurora. So RDS is very easy, if not the easiest way to transition into database as a service. And the reason for this is because the service mimics the on-premises experience very, very closely. So you basically have to provision an RDS instance which maps very closely to the virtual machine models that that Amazon offers, and then they deploy the install bits. They will manage the patching, they will manage the backups, they can manage the high availability as well. The hourly rate for RDS is dependent on the license, so whether you are bringing your own license or Amazon is the one that's basically leasing you the license, how much compute power you pick. So in this case, you have a selection of amount of cores and how much memory and temporary disk you want on this instance. And finally, the storage. So the storage is very flexible. You have a lot of control over it. That's also like a pro and con. The pro is that you have a lot of control over it. The con is that you can also shoot yourself in the foot because of your storage selections. So there's general storage on Amazon, the provision IOPS, there's also magnetic. They all have their different use cases, which kind of falls outside of the scope of this overview, but it's good to know that they are there. So RDS, what's it great for? It's very good for just lift and shift type of move and cloud migrations because the service mimics the on-premises experience, be it physical or virtual, doesn't really matter. It just mimics the product on-premises experience really, really closely. The one thing you have to watch out for is that Amazon does not make every single patch version of all these products available on RDS. They only make some major service pack or Oracle patch levels, for example, milestones available on RDS. So the exact patch level that you have on premises might not map to a patch level on RDS. Now the key there is to not move to a patch level that is below of the patch level that you have, because you don't want to run into any sort of product regressions, right? But as soon as you can tell that Amazon has deployed a patch level higher than what you have, then I would say it's pretty safe to start testing if you have an interest in migrating to RDS. Microsoft, on the other hand, has Azure SQL Database as their cloud database solution. So Azure SQL Database is a cloud-first SQL Server fork. So what do I mean by cloud-first? What I mean by that is that Microsoft now tests and deploys their code continuously to Azure SQL Database, and this type of testing and code and lessons learned all circle back to the on-premises retail SQL Server product. It could be on-premises, could be SQL Server on a virtual machine, but basically the SQL Server on-the-box product. For example, SQL Server 2016 just came out 1 month ago from the time of this recording. In itself, Azure SQL Database, even if you don't have any type of investment for SQL Server, it's also a great database as a service platform because it has a lot of investment on elastic scale, horizontal scaling, and basically trying to help and attract the SaaS provider model. By that I mean the type of model where you have many clients and each one of them has a database. So Azure SQL Database has made a lot of investments to be able to easily scale horizontally, so just add more and more databases as you need more capacity, and also to be easy to manage those databases by pooling resources, to be easy to manage them by doing elastic job executions, to be easy to manage them by doing elastic queries, and so on. So it is a very modern database as a service platform. Now, because it's not like RDS where it maps to a different type of retail type of database products like Oracle or SQL Server or open source MySQL, so it doesn't really have any licensing component, and at the same time it also doesn't give you a lot of control over the actual hardware. So whereas RDS you have to select CPUs and memory and your storage layout, Azure SQL Database does all of that by itself. The only thing that you have to pick is the service tier, and that pretty much just gives you how much power your database has. It has 3 service tiers: basic, standard, and premium, and each one of those has also some sub-tiers to increase or decrease performance. If you have many databases in Azure SQL Database, you can also deploy on a model per database pool to get higher savings by sharing resources. So Azure SQL Database, first of all, great if you have already existing T-SQL skills in-house. If you have a large investment of SQL Server, obviously this is the most natural way to take advantage of database as a service offerings in the cloud. However, it's also a great web scale relational service on its own right. And I think it is because of all these investments made to really support the SaaS model and really make it easy to build an elastic application on a relational service. One thing you have to watch out for, definitely you want to make sure that you do proper SQL tuning to be able to choose the perfect service tier for you. So what I mean by that is that it's really easy to just increase the power of the service and therefore pay more money. Whereas in the past, people might have probably done some SQL tuning before, because on premises it's a lot harder to scale up, right? So scaling up, not just because it's easy doesn't mean it's always what we need to do, right? There's some proper SQL tuning that you can always do to make sure that you don't have to just pay more for raw power. Now, I'd like to give an honorable mention here at Google's offering. It's called Google Cloud SQL, and it's basically a MySQL managed database service. So it's very similar to Amazon MySQL RDS, where you basically select an instance, you deploy it, and then Google will manage the automation of the backups, availability, and so on, or as well to Amazon's Aurora, which is Amazon's own MySQL fork. Okay, let's talk now about the next category of databases as a service. It's what I call the Formula One. So these are fit for purpose offerings. They might not have all the amenities that you're used to when you compare them to the full-blown, really mature relational products. So as you guys can see, that Formula One car, it's built purely for speed, right? It probably doesn't have a cup holder inside. It probably doesn't have heated seats. It probably doesn't have satellite radio, right? So it's fit for purpose. It's just meant to go fast, though you might miss some of the things that you get or that you're used to on your regular car, right? So let's talk about Amazon DynamoDB. This is a very popular service in Amazon AWS. It's basically a NoSQL document/key value table store. So it doesn't force any schema on you. All you have to define is the table and either its key or its key and sort order. And after that, the schema is completely flexible and up to you. Amazon DynamoDB does not have an optimizer, so it does not support just ad hoc querying like a relational product. So it's really more of a set of denormalized instantiated views based on the indexes that you have created on your data. It does not have a fixed schema, but it does support complex types as well. So for example, fields, like I said, is denormalized, so fields could be lists, some fields could be maps, and so on. It's really built for scale out growth, so you don't have to worry about the scale out. You just have to know that that's how Amazon has architected the service. So when you specify a partition key for records, for example, those are all going to get distributed to basically the same nodes that Amazon builds transparently behind the scenes for your data. It also exposes a stream-based API, so if you need to basically replicate what's going on with DynamoDB to another system, you can do so through the stream-based API. One thing to note as well, Amazon DynamoDB does not do SQL querying. It is done through a different type of specification you can easily develop in many languages that Amazon has provided SDKs for, like Java or .NET, Python, etc. But it's not like select star from type of queries. It just requires a little bit of learning to get the hang of it, but it's nothing really major. And finally, the cost of Amazon DynamoDB is based on storage, how much data you have, the I/O rate, so how many requests for read units and write units you're going to make, and also if you have any streams, you're going to have to pay for the streams read rate. So DynamoDB, it's great for scale out of high ingest applications because you can just forget about, oh, I'm going to run out of space anywhere, because Amazon handles all of that through their scale out architecture. But keep in mind, it has to be good for known query patterns. It does not support ad hoc querying, right? So Things to watch out for. First of all, like I said, it doesn't support ad hoc querying, so your schema can have a huge impact on what you're allowed or available to do on your application, right? And it has a finite number of indexes that you can apply. It's 5 global indexes for each table. So you have to keep in mind those indexing limits and how it does not have an optimizer, and make sure that your schema will be able down the line to support your application requirements that might come up. Moving on to Microsoft Azure, we have the DocumentDB database service, and this is a NoSQL document database. So when we mean a document database, it's basically a repository for JSON documents, and JSON documents can pretty much just contain any type of field in themselves. They can have other nested fields and so on. So it's definitely NoSQL denormalized. It has built-in support for partition collections, so you can specify a field in the JSON, and Azure DocumentDB will partition the documents based on those on that field. It also has built-in geo-replication support, so you can have, let's say for example, an Azure DocumentDB collection reading and writing on the East Coast, and then you can have another replica for that DocumentDB collection that you can use for reads off of like Central US, for example. And of course, if there's an issue with the region where you have your DocumentDB, you can fail over then to the other geo region for really, really high availability. There's no schema restrictions on the JSON. Like I said, the system is set up to be really easy to just set up and go. So if you don't specify any indexes, the system itself already has some automatic indexing policies. The billing can be done on predefined tiers, so Azure already offers some predefined tiers based on common pattern usage. But if you really want to customize it, you can easily select your individual compute power, which are called request units, plus the amount of storage that you want for the collection. Okay. So Azure DocumentDB, great for JSON-based storage. Really easy to jump on it and just start storing documents. Really easy to work on the retrieval as well, because DocumentDB does support full-blown SQL style queries. So you don't need to learn a new type of query language. You don't need to learn a new way to specify your queries. Something to watch out for as well is that the indexing, of course, has a storage consumption value. So the more indexes you have, the more storage you're going to consume, and then you end up paying for that amount of storage. Could be for indexes that you don't necessarily use. So just keep an eye out on the automatic index policies. Make sure that it makes sense for you. If a field it doesn't particularly make sense to have an index on because you're never searching on it, then just disable it through a custom policy. And also keep in mind that if specific collections have limits, for example, if you go with a partition collection, then each key will be able to hold at most the 10 gig of documents. So if you need more than that per partition key, you probably want to make sure that you design with a very high granularity partition key. Some honorable mentions here on Google Cloud Platform. For example, Google Data Store is another managed NoSQL service that is based on entities and properties. So again, denormalized. Again, you can have complex entities with other entities. You can have any types of flexibility on the properties as well. Something very interesting of Google Data Store is that it does have built-in ACID transaction support. So Amazon DynamoDB, the transaction support has to be implemented through a library in your application that Amazon has created. DocumentDB will allow for single document transactions. Data Store does have built-in ACID transaction support cross-entity as well. Google Bigtable will also get an honorable mention here. So Google Bigtable doesn't have strong typing. It's basically just a massive key value table, and it just the data as it comes in is just treated as basically just binary strings. It doesn't have any sort of type of querying through SQL or anything. Basically you have the key, then you can get the value, and that's it. It's also built for very, very large tables, so it's not even worth bothering or looking into the service for anything less than a table of 1 terabyte as well. Okay, let's move to our next category, and these are the 18-wheelers. So this is heavy load of structured data. These are basically our data warehouses in the cloud. So number one, and probably again the granddaddy of this type of service, is Amazon REDSHIFT. So this is Amazon's modified PostgreSQL with columnar storage, like all the other columnar storage type offerings like Vertica or SQL Service PDW or Oracle has on Exadata or the new 12c in-memory analytics. All these columnar storage type of technologies, they are all very highly compressed, and they, instead of storing the data by rows, they store it by columns, which makes the scans of the data as well very fast. So that's a relational MPP, so massively parallel processing data warehouse. So it's multiple nodes. It's not just one big machine, and it supports SQL querying as well as writing your own modules on Python as well. So Redshift was scaled per node. So if you need more power, you need to add another node. So that means you have to make a selection of both compute plus storage, and it's also paid per node per hour. Now, Redshift does give you a lot of control on specific node configuration, so you're going to be able to pick how many cores, how much memory the nodes have, and you can even make a decision whether you want, to pay more money and have the fastest storage on the nodes through SSD, or if you have a more loose SLA, you want to save some money, you can just have them have a hard drive based storage attached to the nodes. So Redshift, great warehousing solution for all your data. If you have a big footprint on AWS, Redshift is definitely the warehousing solution that you want. Something to watch out for: node count and configuration. So the ideal configuration of your Redshift cluster might depend on your workload and your workload patterns. So you have to think, oh, well, is it better if I just have, let's say, 6 nodes with really high specs, or does my workload work better if I have 18 nodes with a less compute or less memory, that type of thing? It has to be really analyzed and properly tuned based on workload and the warehouse design. Keep in mind to watch out for copy issues due to S3 consistency. So at Redshift, Amazon always recommends they use the manifest file to specify what you want to load, so that you're not in a situation where basically you just read the names of the files off of S3, and because of the eventual consistency, there was a file that you missed. Also keep in mind that Redshift does require regular maintenance to keep the stats up to date, and if you do any updates or deletes, then it also has an operation called the vacuum to keep the tables in the best shape. Azure SQL Data Warehouse is basically Microsoft's response to Redshift. So again, this is fully relational, so 100% SQL type queries, very close to the just on the box T-SQL for SQL Server. So if you do have SQL Server investments, it will be really easy to adopt SQL Data Warehouse. It's columnar storage as well, and it's also an MPP service. So again, massively parallel processing. It's split into nodes when you load the data, and it also has a distributed architecture where the query gets sent to all the different nodes to help resolve your questions. So interesting for Azure SQL Data Warehouse is that it scales compute and storage independently. So unlike Redshift, where you always have to scale on a full node, Azure SQL Data Warehouse does allow you to add more compute if you only need more compute, and it does allow you to just grow on storage and keep the same amount of compute as well. A very powerful capability it has is that you can actually pause compute completely. So if, let's say, for example, you have your data warehouse running all through business days, and then you shut down on the weekend and there's really not a lot of load on it until Monday, you can actually make a decision to just shut it down and pause it completely during the weekend and get maximum savings that way. So unlike Redshift, where you have a lot of control over the configuration of the nodes, on Azure SQL Data Warehouse, there is no control or hardware either. It's 100% platform as a service. You simply select a compute unit called a data warehousing unit, and the amount of the data warehousing unit will just give you an idea of the power that you get for the data warehouse. So for example, the lowest level is DWU 100. So if you run a query and it took 10 minutes in DWU 100, if you were to go to DWU 1000, the expectation would be that it would be 10 times faster, so it would just run in 1 minute. And that's how you really need to think about it. You don't really need to think about it in terms of cores, memory, or storage. You just need to think about how much raw power I need for this, and if I am getting a certain amount of power right now, how much more or how much less can I live with, and adjust your DW units accordingly. So data warehouse, great for a warehousing solution if you have a lot of data already built on Azure services. If you are thinking of using this as your enterprise data warehouse regardless with on-premises sources, it's really good if you have a PAAS-friendly workload, like I said, because then if your warehouse will allow to pause, you will get really good savings out of this service. Something to watch out for right now is that it is currently in public preview, so not all T-SQL data types are supported yet. So for example, if you need to store some spatial data, you could store it right now just as binary, but you won't have all the support of all the spatial functions at the moment. So just make sure that you go through and look at what is available right now before you start doing an entire migration to Azure SQL Data Warehouse. However, if you just have regular run-of-the-mill structured types on your data warehouse, it's definitely good to start looking into it at the moment. Let's talk about Google BigQuery. So Google BigQuery is really interesting because it's more of a mix of an 18-wheeler and what I call a container ship. So a container ship is what I call a full-blown type of big data Hadoop style service. And the reason for that is because BigQuery can have tables. So these are just regular tables with data that are stored inside BigQuery. It can also support virtual tables, so you can define other type of tables through like schema that it reads off of the data as well. It's the same with external tables, so you can map Google BigQuery to other services inside Google, and for example, let's say Google Cloud SQL, and then have those tables defined inside BigQuery to be used for your analytic queries. So it's also very easy to use SQL querying interface, so you don't have to learn anything new. It has a streaming interface as well, so if you, instead of wanting to just run an ETL mostly based on a fixed schedule batch style, you can also have a streaming flow that just brings inserts directly into BigQuery constantly. Now Hadoop can be attached to BigQuery tables, but it does require a temporary data copy. So if you use the BigQuery Hadoop connector, just keep in mind, if you go into the BigQuery documentation, you can read about it, but it will do a temporary data copy to GCS, Google Cloud Storage for Hadoop. So don't be surprised if you try to do that and you get some GCS costs because of that type of operation. So BigQuery is built per storage, so the amount of data you have. If you are streaming data in, you will pay for that as well. And finally, in the piece that is most interesting about BigQuery is that you only pay for data read by queries. So if you have, let's say, a 20 terabyte warehouse in BigQuery, but you're only running, 1 to 10 queries per day, you will only pay for those queries. You don't have to pay for provisioning compute storage like you do on REDSHIFT, and Azure SQL Data Warehouse, you also pay for compute, but at least you can pause it. But BigQuery goes one step forward as well, and then you can only pay for specific queries that you run. So you don't even have to think about starting and pausing compute with BigQuery. You just simply use compute on demand whenever you feel like running a query. So BigQuery, great to be a one-stop shop if you have streaming data, if you have relational data, if you have file-based data, because of the way that it can put schema on read. Watch out for high compute queries. So basically, if you have a query where Google estimates that it takes too much compute to resolve to their regular rate per query that reads 1 terabyte, is $5 per 1 terabyte at the time of this recording, you might get an error message that just says, hey, you need to run with higher compute, and then the cost of that query will be higher. So you have to keep an eye out for those type of runaway costs. And finally, in the explain plan of a Google BigQuery, you can actually see how much time you spent waiting to get scheduled on a Google's compute fabric, and you are allowed to call Google support and ask to pay for a reserved compute slot. So basically that time always goes away. So usually in my experience this time has always been tops a few seconds, but if you have some type of mission critical dependency on BigQuery where you can't allow this to fluctuate too much, you can actually pay for a fixed reserved compute slot on BigQuery as well. Now let's talk about the container ships. So these are basically carry everything, any shape or form, big data systems. So it's more aligned to what we just basically think of as Hadoop. And really, it's Hadoop as a service, and is very attractive because if we think about on-premises Hadoop deployments, they do have a high cost of what I call the high cost to experiment, the high cost of curiosity, right? You have to build your Hadoop service, you have to have enough storage, you have to have enough nodes, and then you can start doing your data exploration. Whereas if you do it in the cloud, you can just let the cloud deploy all the amount of power that you need. You know, if you really need a really big cluster, you don't have to make any type of cap expenses to get that up and running. You don't have to have an operational management of that cluster either. You just simply create and destroy as needed, and you can have yours paying for your storage mostly in the cloud. So all the major cloud providers offer this. So Azure has HD Insight, Amazon has EMR, Elastic MapReduce, and Google has Google Cloud Dataproc. And they all follow a similar pattern. So you pick some sort of machine model for your nodes, you deploy the cluster with a given size, right? You pick how many nodes you want, and then you hook it up to a storage service that it can read the data from. So in Azure, this could be Azure Data Lake, it could be Blob Storage. In Amazon, this could be from S3, and in Google Cloud Dataproc, this could be from GCS, Google Cloud Storage as well. And once the cluster is deployed, well, you can basically just use it as any type of Hadoop installation if you need to run MapReduce or Spark or Storm or any other type of Hadoop-based service. One service that I wanted to call out here for as far as containers, because I really think is really interesting and has a lot of promise, is Azure Data Lake. So Azure Data Lake is currently in preview right now, and this is Microsoft's one step up from just Hadoop as a service. And what I mean by that is that it's separated into storage and analytics. So I have the storage service that has no limit on size, no limit on the size of a file either, and it also has an analytics service that can run big data jobs on demand. So very similar to how BigQuery just runs queries on demand, that's how the analytics service works for Azure Data Lake. So because it is mostly just a big data type of repository, you can mix tables, you can mix files, you can have external tables, and it does all this through what they call uSQL, and it's a mix of SQL and C#. So if you have already DBAs in your company, or if you have developers that are familiar with SQL and C# in your company, it is very easy for them to be productive really fast with Azure Data Lake without having to learn all the different pieces of the Hadoop ecosystem like Pig and Hive and so on. On top of that, if you do need a full Hadoop cluster, because let's say you want to use some MAHOUT algorithms on your data, you can actually attach an HD Insight cluster directly to Azure Data Lake and then run from that. So very powerful because you have the option of just on-demand analytics through uSQL, or if you want a full-blown Hadoop cluster, you can just attach it to your Azure Data Lake account as well. And like I said, the analytics are done per job, so you can really control your cost of using the service. And they can also be scaled dynamically to increase compute, or what they call an analytic unit, which is basically, just think about like another node that is running your queries. And it's built by storage, it's built by the analytic units that you use per job, and then each time you submit a job, it has a fixed cost as well. So Azure Data Lake, I think, is great for leveraging T-SQL and .NET skills to make really easy platform as a service big data analytics. I've demoed this service to other DBAs, and they've been really excited because they suddenly see how basically the barrier of entry for doing big data analytics is really low with Azure Data Lake. The only thing to watch out for right now is the service is still on preview, so it has a limit of 50 analytic units, so 50 nodes when you run a job, and 3 concurrent jobs per account. However, if you do have a strong use case, feel free to reach out to Microsoft support and they can lift those restrictions for you. Okay, so let's do a recap of what we saw today. So number one is the COROLLAS, right? The classic relational in the cloud. You know what you're getting, you know what to expect. Then we have the formula ones. These are built for purpose. They might not have all the amenities, but it's all to grow and ingest data and query data really fast. It's the NoSQL in the cloud. Then we saw the data warehouses in the cloud, the 18-wheelers. These are all about accumulating a lot of structured data and really easy querying that large amount of structured data. Finally, we saw the container ships. So store anything and everything, any shape or form. These are big data in the cloud. Mostly all providers have some sort of Hadoop as a service offering. There are also some providers going one step up from that, like Microsoft with Azure Data Lake as well, that provides on-demand analytics, on-demand attaching a Hadoop cluster to your data as well. So think about this. We have a tool set now. It's not just one hammer. If we were 15 years in the past, many of these systems would have just had to be built on relational because that was the only mature technology that we had at the moment. However, nowadays, you can actually sit down, think about what you're trying to build, think about your requirements, and just pick one of these tools from our tool set. Think about that database service platforms, they can improve delivery because all the management tasks are automated, so less chance of human error, less chance of quality issues doing the actual maintenance work. It's faster to deploy, so time to market is reduced as well. You don't have to use a big capital expense to get up and running, to set it up, to maintain it, and because of that as well, you get a faster return of investment. However, you have to understand them well. You don't want to, go into a DOCUMENTDB deployment and then realize down the line that what you needed was a relational. You don't want to go into a REDSHIFT deployment and then realize down the line that you'd have been better served with something like Google BigQuery. So you have to understand all these services really well. And in the end, a modern data architecture that we see with our clients really takes into account many, if not all of these. Most of our clients that really want to leverage their data to give them insights, to give them competitive advantages, they all have some sort of relational data, some NoSQL unstructured type of data, and some big structured data requirements for warehousing. And many of them are now also investing and adopting and embracing big data, and the cloud makes it really easy to just deploy for big data and to do analytics on big data as well. If you have any questions, any follow-up, feel free to just shoot me a Twitter at warchav, or please visit us and contact us at pythian.com. Thanks for watching, and until next time.